First section in topic 2C is 1.5, solving equations and inequalities by graphing. So we got a couple vocab words: solution to an equation, anything we can substitute into an equation, a number that we can substitute in for a variable, and makes the equation true. For instance, x plus 5 equals 7. Well, x equals 2 is the solution because when we plug it in, yeah, 7 equals 7 last time I checked. System of equations: one or more equations happening at the same time. And a solution to the system of equations is a common point between those lines or equations. So we can have one solution where they just intersect once. We can have no solutions when they're the same or they have the same slope. And if they have the same slope, they're parallel. Or they can have infinite solutions if they're the same line. So we're going to look at this first example. Use the graphs to solve the equations. So look for the point where they intersect, and the solution is the x value. Just like we were dealing with interval notation, all our intervals were x's. It's the same idea. So in this first one, well, we can see where they intersect right there and right there. So x equals -2 for that first one, and x equals 3 for the second one, just where they intersect. So we had two solutions there. This next one, we only have one, right there where they intersect. So x equals -6. We don't care about the -5. We care about the -6. And solutions here, well, we got two again at x equals -6 and x equals 0. So it's just the x value where they intersect, nothing super crazy. All right. So let's solve this equation, -3x plus 20 equals 5, algebraically. So just like what we always do, get the variables on one side, get the numbers on the other. So we'll subtract 20 first. The 20s cancel out. We have -3x equals -15. Divide by -3, and x equals 5. Well, we're going to do the same thing, but we're going to do it graphically, and we're going to use our good friend Desmos. So in one of them, we're just going to put 5. And the other, we'll put what the other side of the equation is equal to. So all we did was split this up into that equation and that equation. And we're just going to see where they intersect. So y equals 5 and -3x. Oops, should probably put y equals -3x plus 20. All right, we need to get some points here and graph these. So, well, our horizontal line is at x or y equals 5. So that's our y equals 5. Then for y equals -3x plus 20, well, let's get some points here. Nah, those are still too big. They don't show up. All right, now we got some points. So I think we can do 4, 8, barely. We can do 5, 5, which of course is our intersection. And we need at least one more so we can have a decent line, and that's 6, 2. Connect them. And of course, their intersection, this point here, we want the x value. So this is the 0.55. So x equals 5. I guess so does y, but that's not quite what we're looking for. So we can do a couple more of these. Now we have absolute value and a line. Okay, doesn't change anything that we do. So let's move over here for this one. So y equals negative absolute value of x minus 2 and y equals negative 1/2 x minus 2. Maybe we need some points. It's not clear where they are. I would go a couple more points just so we can see where the vertex is of this absolute value. So our vertex is at 2, 0. That's our vertex. And then we have points there and there and there. It's negative, so it's opening down. And the slope is 1, so it's just down 1 over 1. So that's our absolute value. Now the line, well, it goes through negative 2 because that is our y-intercept. And then we go down 1 over 2, down 1 to the right 2, down 1, right 2, and so on. So we actually have two solutions. Hopefully my graph is accurate to what they should be. So 8, negative 6, and 2, 0. All right, so 8, negative 6, well, I was a little off. 8, negative 6. And then here we have 2, 0. And again, we only want, so we intersect at 2, comma 0 and 8, comma negative 6. But our solutions are x equals 2, x equals 8. It's just the x values. We'll do the same thing with this one. We have absolute value again. So actually, I'm just going to change what I need here. And we'll get rid of that. And now it's 1/2 x plus 1. And again, we have our points, but I still want to get, there we go, more points. And again, what the heck? So here, we want to at least get the vertex and 1 point on either side of it. Our vertex is at 4, 0. And we have another point at 5, 1 and 3, 1, 6, 2, 2, 2. So that's our absolute value. And then our line, right? So again, we want some decent points. So we'll graph the y-intercept, which is a positive 1. And then our slope is up 1 over 2, up 1 over 2, up 1. Oops, yeah, that's right. Up 1 over 2, up 1 over 2. Connect those. And really, we probably should just look at the Desmos graph because my graph is not fantastic. So we have intersections here and here. So that's 10, comma 6 and 2, comma 2. So x equals 10 and x equals 2. All right, so there are the directions for the calculator, but we're using Desmos, so it doesn't really matter too much. Let's do these last two. So now we have some more complicated things here. We have a quadratic and an absolute value. So y equals negative x squared plus 8x minus 13. And we have the absolute value of x minus 4. Yeah, and these points are not nice. So let's graph our quadratic first. So we want the vertex, which is at 4, 3. And then we want 1 point on either side of it. And if we really want a good line, we can get the next point. So that would be, let's see, 2, negative 1, and 6, negative 1. So it's a little bit harder to get these to be accurate, our quadratics anyways. All right, now we'll look at the absolute value. Not too crazy. Again, let's get our vertex. So our vertex is here at 4, 0. And then we have points here and here and here and here. So it looks like that. Now the problem is the intersection points. Well, there's one, but I can't see it. So those are our intersection points. So we won't go crazy with the decimals. Let's just say 5.30, comma 1.30, and 2.70 and 1.30. So the reason they're both solutions is that they have the same y value, but our x values are the solutions. So approximately 5.30 and approximately 2.70. And round to whatever they say to round to. They say hundredths, we have 2 decimal places. They say thousands, we have 3. Tenths, we have 1. One more problem, very, very similar. Just start fresh. So our first one, y equals x squared plus 2x minus 1. Actually, let's graph that one first so it's not as crazy doing everything at once. We have our vertex at -1, -2. We have other points at 0, -1, and -2, -1. So it's opening up. It looks like this, give or take. Then we put in our other equation, absolute value of x plus 2, close the parentheses, plus 2 again. And this should be y equals. Doesn't really make a difference. So we have a couple points here. Get some more. Again, we want the vertex. We have it at -2, 2. So let's get -3 on here as well. So we can get the 2 points on either side of the vertex. So we said our vertex was at -1, 1. And then we had points here. So goes through that, goes through that. And again, the intersection are not whole numbers. Let me get rid of that so we don't see all those points flying around. Because we just want that one. We'll have to look at the second one in a second. -3.30, comma 3.30. And 1.79 and 5.79. So our x's are -3.30 and 1.79. I guess they should be approximately, not equals, because they're not exactly equal to that. And That's what we're doing for our solutions. Now, our inequalities, same type of thing. So to finish this up, we'll talk about inequalities. So inequalities compares two values, showing if one's less, greater, or not equal to the another value. Solution of an inequality is a set of values that satisfy all the, or satisfies the inequality. So it's the shading part. All of this works. Systems of inequalities, it's where they both are shaded. So the overlapping would be here. That would be our solution. And we have our symbols here, greater than or equal to, less than. So we need to make sure that we know which is which. Okay, so x squared minus 4 is less than 0. So we're going to solve this by graphing this. If I can find Desmos. And we're not going to do it by hand because we got better things to do. So we have x squared. I'm not typing it in the right place. X squared minus 4. So let's get some points so we can graph that. So we have 0, negative 4, negative 1, negative 3, 1, 3, and negative 2, 0, and 2, 0. We graph it up just like we were doing before. Now this says that we want less than. Less than 0 would be negative. That's less than 0. So we want the part where it's negative. Well, that's all this. It's all negative there. So we put our start and stop of where those boundaries are. And that's right here and right here. So it's negative 2, comma 2. It's our interval notation. It's negative from negative 2 to 2. Any values between those two will work for our inequality. The inequality notation would be negative 2 less than x less than 2. Not less than or equal to, because we don't have that. And x is sandwiched between those two because, well, literally it's sandwiched between those two values. We got another one, a little bit more complex quadratic, but nothing that'll kill us. So we have x squared plus 6x plus 5. Again, we want to see less than 0. So it's our negative interval like we did in the first chapter. So let's get some points here. We want to get our vertex, which we don't quite have. So we'll backtrack to negative 3 and negative 4. So we'll graph our vertex, which we said was at negative 3, negative 4. Then we have negative 4, negative 3, and negative 2, negative 3. But we also want to graph our x-intercepts. So negative 1, 0, and probably need to go back one more space, negative 5. Like that, that. And again, we want less than, so the negative interval. So that's all this. An interval notation, it's from negative 5, including negative 5, because we have the less than or equal to symbol, and it goes up to 1, including 1. So our inequality notation would be very similar to the last one, except we have less than or equal to for both of them. And make sure they're going the right way. If we were to write this going that way, yeah, sandwiches or x is sandwiched between those two. However, if we were to take out the x in one of those, we just told me that negative 5 is greater than 1. Obviously, that's not true. So we always need less than symbols if we're putting it in between two values. All right, let's move on to the next one, slightly different. We have two different functions, and we want to know when f of x is greater than g of x. So that's when the y is higher on the f of x than the g of x. So y equals 3x. Oops, forgot the x part. And y equals 2x plus 2. Let's get some points so we can make it nice. So y equals 3x goes through the origin, and then our slope is just up 3 over 1. We have that there. Then for the second one, well, our y-intercept is 2, and our slope is 2, so we go up 2 over 1, up 2 over 1, up 2 over 1, and so on and so forth. So somewhere here, so the black is lower than the red, and then all of a sudden the black is on top. It's higher than the red. Where is it? Right there. So anything greater than 2. So x is greater than 2. Because anything else, that's where black is above it, and that's f of x, which is what we want. So in inequality, oops, that would be the inequality notation. The interval notation would be 2 parenthesis positive infinity. It starts at 2 and it goes to the right for forever. Right. We got one more problem. Very similar to the other ones that we did. And this may be very similar to a problem on the LTQ. Hint, hint, wink, wink. Oops, I don't want that. So again, we need to get some points. And we want the vertex, so we're going to have to backtrack a little bit with -3, -4. So -3, -4 is our vertex. Then we have -4, -3, and -2, negative. Oops, that's -4, -3, and -2, comma 3. So we got something. Actually, we should graph our x-intercepts as well, which is -1, 0. And if we go a little bit farther on the negatives, we got -5, 0. So that's what it looks like, but this is greater than 0. So we want the positive intervals now. So that's this part. So it's here and out. So in interval notation, this first side, it starts all the way at -infinity, and it goes up to -5. Not including -5, because it's just greater than, union, and it starts up again at -1, and it goes to positive infinity. Our inequality notation would be x is less than -5, or x is greater than -1. And that's how we do stuff with our graphs to solve equations and inequalities.